learning target is posted. Please make sure you get your notes updated. And we'll get started in a second. It's really close.
So sweet.
No Ronnie. Chanel, where's Connie? Okay. All right, I'm going to ask you to help me get her caught up when she gets back. Don't they have a game today? You don't know? Okay.
I know our basketball team does.
You coming?
I'll be there.
Whose list did you get on?
Never mind, I won't be there.
Hey, I'll put you on my list. I don't care.
There you go, Jesus.
All right, we are continuing on lesson 4, or chapter 4, lesson 1.5. Learning targets today. Justice. Hey, welcome to class, man. Can you read the learning target for us?
Students will be able to create and solve real-world math problems using the table ratio.
I had you read it because when I read the words real world together, I really have to slow down because it doesn't come out very well. So thank you for that. I always wish students will be able to create and solve real world, and it doesn't come out. So real world. So you're telling me, Justice, that math can be used in the real world?
Well, I think it's what your target's telling you.
That's what the learning target is telling you. Good. Okay, so we'll see at the closure today whether or not that's true, but that's our goal for today. That's our learning target. With your notebooks out, notebook set up today, we are still in chapter 4. You can choose. Do you want to retain your notebook from first semester or start a new one? I would recommend retain it if you have room, because we started unit 4 at the end of last semester and we're continuing it, and I would keep those notes. Also, there's things that we're going to look at today that have to do with angle relationships that are also in our first semester notes that keeps coming back. Math is very cyclical. We keep using information that we learned and we reuse it as we learn more, and it just builds on each other. Okay, so you might want to put a little piece of tape or a tab or something, mark in your table of contents that we're moving on to a new section, a new semester, but we are still working with trigonometry from unit 4. Notebook setup today, 2-3, lesson 4.1.5, clinometer. Whoa, clinometer, that's our word of the day. That is a tool that we'll be using today. Who's used one already in their lifetime? Ms. Reynolds, me, Ashton?
I think so. What is that again?
I think so. I think I took geometry at one point in time.
Oh yeah, I think so.
Okay, believe it or not, you've probably seen a clinometer used while just driving around. You just didn't know it was being used. And we'll talk during a closure today about what that was. That's a protractor, but it's close. Protractor's part of it. Okay, again, the learning targets listed on top of your notes, so we can look back at our closure at the end of the day and make sure we learned what we were supposed to learn. Leaders fight your closure. Warm up for today. Who likes free money? Okay, my side job is doing construction and things. That's why I use a lot of geometry. But we're going to use this as an example for today. Cell phones are amazing tools. Unfortunately, that Siri and the Google machine and all that, it limits how much we sit and think. So for this question, I'm going to ask for this warm-up that we think, then ink, then share. So I'm going to give you a minute and a half to think of this question before we write something down, and then you're going to work with your table groups to come up with ideas. Okay, the question states, Lucas, can you read it for me?
You were offered $1,000 by your homeowner to determine if a tree would hit their house if it was cut down. What information would you need to know, and how could you find it?
Perfect, thank you, sir.
You understood?
I would love an extra $1,000 in my pocket just for telling somebody if a tree's gonna hit their house. But I wouldn't wanna make sure I'm right. Because I guarantee you if it hits their house, that's more than $1,000 worth of damage. Remember the ice storm we had last year? I had to cut down 2 trees out of my backyard because of that ice storm. And I had to know the height of the tree so I could get an accurate quote from the tree company, how much it was going to cost me. Did I climb the tree? I didn't climb the tree. I use a clinometer because I'm a math teacher and that's what I do. So I want you to think, what information would I need to know to determine if a tree next to a house being cut down is going to hit the house? What types of information would you need to think about, and how might you figure it out? Give you about a minute 15 seconds to think first. Then when I tell you to move forward, I want you to write down a couple ideas. Don't worry, this isn't graded. This is just to lead us into our next topic. But I want you to start thinking about why we would need to know the information that we're going to be learning today. Start to understand the real world situations that we might use this map. Who's starting today? Are you starting today? No. How many practices did you miss?
I'm guessing it's
Although Justice is going to boo me from the sideline if I don't start certain people.
Oh, what? Oh, Chance?
Oh, like when I took Chance out for like a minute and they're like, oh!
Hey, that wasn't even me. I'm just guilty by association.
Okay, make sure you write something down. What information would you need to know? How could you find it? Again, doesn't have to be the perfect answer. Just please write something that shows me that the thought process has started. And then you'll be able to look back at this at the end of the period to see if your thoughts changed at all from then till now. I am missing my blue. I'm going to need my blue. That's a Sharpie. That's a bad idea. Sorry.
I'm just gonna say it back here.
Huh?
Okay.
Oh, did you find one? Oh yeah, look at
Blue
that.
and the black.
Okay, go ahead and share with your table group what you wrote down, what type of information. Don't worry, right now, I'm not going to make you share this with the class. You're going to talk to each other, and then we'll move forward and see if you're right as we move forward through the lesson. So go ahead and share what information you thought would be important to know. And if you were able to take it to the next level and find out not only what information you need to know, but how you might find it, go ahead and talk about that. I'll give you about a minute and a half to talk with your table group, and then we'll move into the lesson. Okay, good break, guys. Anybody have anything else? Same information? You agree with him? You disagree with him? It's still 1 minute before noon, so we're not awake yet. We'll get there. What's that? What are you writing about what? Oh, who's starting? You always want to know first. changed a few times. Lawrence has only started 2 games. One with me, one with Connor.
How's the game?
Okay, I did hear a few key words as I was walking around. Distance, height, angle. I'm glad we're starting to think about those types of things because that relates to what we've been talking about in trigonometry. Glad we're using our heads to think about, okay, so what did we just learn about and why would OG be asking this question? So it must relate to something we've been learning. So I like that we're on the right process. Okay, from now, please take a look at your seat. You are either A, B, C, or D. Based off of what seat you're sitting in, please write down that problem in your notebook that's up on the TV screen. Write down the ratio and solve. If you have extra time and you get it done, Justice, what's up?
I'll wait for you for this.
Huh?
I'll wait for you.
You'll wait for me?
After this.
Aw, that's kind of you. So if you are at seat A, make sure you write down A. If you're at B, write down B. Go ahead and solve. By the end of this, I hope that you have all 4 of these in your notebook. But please start with the one that's your group. And then we'll talk about these and we'll move forward. Remember back, these are ratios. First couple go back to algebra. The next couple go back to the last unit. Yeah. Hey, that's why this, let's see, we're up there, we're on top right, what's the last word? Top row. Last word. Okay, so if you ever come into class and you see something on the screen and it doesn't look familiar, and it says review, that's a great opportunity to get it in your notes. So that way now you're caught up from something you missed. So at least write down the equation, take a look at it, see if there's anything you remember you could do. If not, hold on. The whole unit. Ah. So you went with Chance and Lucas?
They went with me.
Oh, right. Because we already established you're the center of attention, right?
Yeah.
Is that why you didn't play basketball this year? Because of football?
Yeah.
What about next year?
I'll probably be back next year.
All right. Lucas already told me he'd play. We're losing a lot of amazing seniors. Right, Ashton? What's up?
Just that.
You're on the right track. Good job. Yo. Grading on the see, put the grades in Canvas, but the grade in student is one. It has a weight. All right, bring it back to board 5, 4. Okay, so if we go back in time to our algebra days and we see 2, what are these called? We have a number on top of a number. Fraction. Okay, go back back to our learning target that we started talking at the beginning period. We're talking about tangent what? You see it? Ratios. It's okay to say it louder with confidence. These masks kind of muffle our confidence, so feel free to say it. Okay, these are just ratios. 3 to 4, 9 to x. In algebra, when we had two ratios or two fractions side by side, they were equal to each other. How do we solve those? Yeah, cross multiply. Some teachers use the butterfly. Have you ever see that movie, Butterfly Effect? It's been a long time. Every time I ask if they've seen a movie or not, I always age myself and roll the dice whether or not you've seen it. We're going to cross multiply on there. So now, enhance your notes with use of what? Color. I like using color in my notes because then when I look back at them later, it helps me remember what I did. So when I cross multiply, I'm going to do this and say 4 times 9. And then I will do this. And I will say 3 times x. And I'll get my black and throw in my equals. That's a terrible pen. Okay, 3 times x I know is just going to be 3x. And 4 times 9, I'm going to use my 9's trick and put down my 4th finger to know that 4 times 9 is 36. So that way I don't just quickly go to my calculator to try and find basic math. What do I do next? Divide by? Good. Divide both sides by 3 to give me x equals 3 goes in there, 1, 3 goes in there, 2, x equals 12. So if I look back at my notes later, I would maybe see this and I would realize what those little circles mean because they're circled in blue. Blue goes with blue, red goes with red, and it gets me down to my solution. What is the difference between the first set of ratios and the second set of ratios? If you know anything different, besides, of course, the numbers are different? Louder? I know. If you're going to be the center of attention, you got to be louder than that.
X is on top.
X is on top. When I have a ratio or a fraction and x is on top, what's that called? The numerator. When the x is in the numerator instead of the denominator, does that change how we do the problem? No. So we are going to still do our butterfly. And do it this way. Red is 21x. Blue is 12 times 35. 420. Somebody want to check me? We good? 21x equals 420. And what did I do over here to get x by itself? I divided by 3, so what am I going to do here? Divide by 21. Divide by 21. Leaves me with x equals 20. Good. So a lot of us are comfortable with this. We've done it enough times, we've practiced it. Then we get to our final, or our Unit 5 test, and we see something like this. And we start to freak out, because it's something new, something different. So we freeze. Go back to prior knowledge. Use this information and set this up the exact same way. Tangent over 52, I can just put that over 1, because I know anything over 1 is just itself. And I'm going to set up my butterfly again. Exactly the same. What is x times 1? Just x. And then I'm going to put 12 times the tangent of 52. I'm leaving my pens open too much. 12 times the tangent of 52. Somebody please grab their calculator for me and type in 12 tangent 52. Enter. 15.35, which rounds to 15.4. X equals 15.4. If we want to be picky about it, since we rounded, we can say that X is approximately 15.4. Okay? Take what you know, apply it to something else. Just because it's not set up as a ratio, tangent just means a ratio. It's the ratio between the sides of a 52-degree slope angle, which we learned about when we got introduced to tangent. Who got D, looked at it, and said, oh crap. Okay? Last period, almost every person that was sitting at D looked at that. I was like, oh no. Okay, that's the one that we practiced the least. But I'll tell you right now, it's the easiest one. Because I can pretty much put my markers down because it's already set up for me. Okay, we have two sides. Think back to triangles. Because when we're doing ratios, what are we trying to find here? We're finding a side length based off of an angle. What's missing here? Our angle. We have two side lengths, we need to find the angle. So instead of using tangent, what are we going to use? Second tangent on our calculator means inverse tangent. Given side lengths, trying to find the angle. If I looked at this as far as a triangle is concerned, the x is the slope angle that we're trying to find. What's provided is the 2 and the 5. Opposite over adjacent. Everybody do me a favor, grab your calculator. Make sure it's on. Hit that second button in the upper left. Hit tangent, which gives us, what does it say on your screen? Should say tangent to the -1. And then put in 2 divided by 5. And what do we end up with? 21.8, and we round angles to the nearest whole degree. X is going to be 22 degrees. So we started the period, and D was probably the scariest. Hopefully now moving forward, that one's actually the easiest. I didn't need to set up cross multiply, I didn't need to do any of that, I just Tangent ratios are built into our calculators, and they do it for us. We started learning specific tangent ratios with 11 degrees, 22 degrees, 45 degrees with a 1-to-1 ratio. They're all built in there for you. This was a little bit of review, but we're going to use this today. Are we all comfortable and confident setting up and solving cross-multiply problems involving tangent? Okay. This I'm okay with. Hopefully by the end of the period we move it to at least here. Okay? But if there's anybody that's totally lost, pull me aside when we do our activity and I'll help you out. This is the time where I look around and I find my mouse. Okay, as a little bit of a review, when we talked about tangent, we were introduced to it by doing slope. Remember, slope from algebra is what over what? Rise over run, which is what we have here. Delta y, delta x. Delta y is just our change in y, our vertical change. Delta x, horizontal change. So if we look at our rise and our run, what creates is a slope angle. That's our tangent that we're referring to. That's our reference angle. So tangent is always going to be our rise over our run. If we look at where that angle is, rise is always on what side of the triangle? I'm pointing. This is your easy time to participate. You just have to read what I'm pointing to. Opposite, good. Run is adjacent. Okay, we'll get there with the other one. What's the other side? Because the triangle has 3 sides. The slope makes the hypotenuse. You probably heard the word hypotenuse when we talked about Pythagorean theorem. That's the c squared. Okay. As we get into sine and cosine, that'll come into play more. As for right now, we're not going to worry about it as much. Tangent is rise over run, which is opposite side over adjacent side. Clinometer. You can thank my buddy Mr. Strickland down the hall for this beautiful picture. I don't know what's better, the beautiful tree or the amazing clinometer. So give him a pat on the back. But here's your introduction to the wonderful tool that you'll be using today. Please pay close attention to these instructions, because if we go outside, which we're going to do here in a little bit, to do this activity. What? Sorry, wearing shorts. I know it's a little cold, but.
No, it's not cool. It's not
Okay. You're just baffled. Why would we go outside for a math class? Math belongs in a classroom, right? Well, I'm going to challenge that today. See, look at that. Look at that beautiful clinometer. It's pretty much like the real thing. We use a clinometer to measure an angle, which we learned. This is, what Greek letter is this? You remember? Theta. Good. Theta. Theta is just a variable. It's a Greek letter that we often use to identify missing angles. We're going to use this to identify or get to what our theta is. If I draw magically 2 lines, okay, there's a weight on this string which keeps it what? Balanced, or it rhymes with vertical. Vertical, good. Look at that. Because it's vertical. We want it to stay vertical. Because if I have a vertical line and I'm measuring the height of something, what does that tell me about those 2 lines? They're both vertical. They're both perpendicular to the ground, making them. Lucas, louder.
Parallel lines.
Parallel. Thank you, bud. And if I have parallel lines, if I look through my straw and it creates this line, ooh, if I look back at my notes, I see a lot of things that look something like that, where I have parallel lines with a line that goes through them, which is a transversal. Only difference here now is we are focusing on this piece. But we learned about angle relationships, and we learned about this angle, which is B, and this one, which is A. They are what? Same place in 2 intersections, make them corresponding angles. This angle is equal to that angle. How does that help us find theta? We're going to use another theorem that we learned.
Theta's the angle, right?
Theta's the angle we're trying to find.
What is
Okay.
it
If we find this one, which equals that one, so we know that one, and we know that one,
They equal 180. Right?
based off the triangle angle sum theorem, we know that those 3 are going to equal 180.
So you just minus those from 180.
Good. So I already know that's 90. Let's make it easy. I know that 90 minus A is going to equal theta. That kind of looks like a 9. Let me shorten that up. So I'm going to do my measured angle. which is my corresponding angle. I keep losing my mouse. I should get one of those surfing wrist straps. Just attach it to me, so that way I just drag it around everywhere. B and A, we know our corresponding angles. I can take 90 and subtract that measurement in order to get my theta. That is our angle of elevation. When I'm using my clinometer, if my angle of elevation was 0, it would be flat. No angle of elevation. As soon as this starts to point up, I go up 10 degrees, 20 degrees, 30 degrees, 40 degrees. But if I look at my protractor, that says 80, 70, 60, 50. That's not the angle of elevation, is it? When it's at 80, it's actually 10. That's why I take my 90 and I subtract my A. This is 90. I'm sorry, if this is 80, it means this is 10. 70 would be 20. 60 would be 30. This is why this is important. You as a class are going to go out to the football field and start measuring some things. You need to know how to use this. I will give you an example. You're going to go out there, collect data, and bring it back in, and we'll solve at the end of the class period. You're going to take a clinometer. You're going to pick an item, like the M in the clock. I'm going to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tiles away. Because I do construction on the side in the summers, I know that these tiles are 12 by 12, meaning I'm now 10 feet away from that clock. Distance away is 10. I will look through my clinometer at the M in PM until this stops swaying. A member of my team is going to look and see what the angle measurement is. That looks like, to me, 71. So what is the angle of elevation if my measured angle is 71? 19 degrees of elevation, because 90 minus 71 gives me my 19. I'm going to put that on my data sheet. I now have distance away, and I have my angle. If I put that into something like this, and I have my clock with my M, my distance away was 10, my angle of elevation was 19, and I'm trying to find how tall it is. This might look like something we've been doing. This might look like something that was on the final. This might look like something that was on Unit 5 test. But in the real world, I could measure from the ground to that M and figure it out. But what if that clock was about 20 feet higher? I wouldn't be able to get to it. And that's what our goal is today, is to find the measurement of things that we can't necessarily reach. Distance from object. We can set up our equation just like I did. Oh, I didn't set up the equation, I just drew your tangent. 19 equals opposite over adjacent in order to solve for x. Okay, one thing to keep in mind, if I solve for x here, I'll do it real fast. I'll try to speed up so we can get you guys outside and have plenty of time. I'm going to cross multiply that to do this, so I'm going to go x equals 10 times the tangent of 19. 10 tangent 19 equals 3.4. Wait a minute, Oglesby. There is no way that that M is 3.4 feet off of the ground. Make sure you add in your eye height. because I am measuring from right here. So that triangle that's created is from my eyeball. That's the roughest stick figure you're going to get. I need to add in the distance from there to the ground, which is the distance from the ground to my eye, in order to get my 3.4 to be the actual height. Do not forget your eye height when you do these problems.
6 feet 2 inches.
Common mistake. Height of object equals x, which you solve for, plus your eye height. Resource managers are A today. If you are sitting in seat A, I need you to make sure you have at your table group the following things. One each per group. You need a whiteboard and marker, a resource page, which, would you mind handing those out one? Resource page, an envelope that has a clinometer in it, a measuring stick, which are here, and you can choose if you want to take a calculator out there with you, just in case you want to do some of the calculations outside, but hopefully we'll have time to come back together at the end of class and do some of the calculations in here. So that's up to you. Take the calculator with you, or wait till you get back in class. Okay. I'll give you about a minute for the resource managers to make sure you have all the resources you need at your table before we move on. Ready to go? Ready? Huh? Yeah, so are you. While we're outside, we'll just have you run around the track. Warm up for the game. You gonna shoot for like 6 hours? I did 2,000 meters after practice yesterday. I'm a little bit sore too.
Of what, the
Rowing. I did the first 1,000 meters in 5 minutes. I was like, oh, I wonder if I can do 4.
You tried it?
I tried it. I did 4.4 seconds. 4 minutes and 4 seconds. I was like, oh, okay. But then I was too tired to try it again. So maybe today after the game
Oh, we can do like 4:30.
Okay, please take a look at your team roles that are up on the board. These are going to rotate. We're not going to stay as the same thing every time. There's 4 people per team. We have 2 groups of 3. So I'll have my group of 2 actually split off. Sorry to split you guys up. And I'll have you join each of the groups of 3. So we have all groups of 4. The reason being because each person needs to do one of these tasks 1 time each. We will have the clinometer operator. We will have the person that reads the angle off the clinometer and determines the distance away from the object and records those to the data recorder, who's going to put those on the sheet. And then we all have a calculator. The person will take all the data and solve. So we're going to measure 4 things per team, and you will do each of these things 1 time. On your resource page, please write each of the table group members of your team. Right here where it says name of recorder, it should have each name listed in the box. We are going to release from class. We're going to go out to the football team safely, staying on the sidewalk, staying out of the parking lot. I will open the gate. There are a lot of things out there that you can choose the height of. Be creative. If you have questions, you can ask me now or out there. There will be multiples of us floating around. Grab somebody if you need help or direction on what we're doing. Okay? How many different things are you going to do? 4, 1 of each. Please make sure you're rotating. If I get a sheet turned in that has handwriting that looks all the same, that'll tell me that the same person was the recorder the whole time. Mix it up. I don't care if you have bad handwriting. We'll get through it. Obviously, so do I sometimes. I think that was my last slide. Okay, today, there's There's no homework. So I'm going to double down on this. Your opportunity to start semester 2 with an 8 out of 8, 100% in this class, is by turning this into Canvas at the end of the period. At the end of the period, you're going to take a picture of this and submit it in Canvas. Double these points. Here's your rubric. If you and your group get all 4 done, complete, you'll get 8 points for just being here today and participating in real world, see how I slow down, real world math on a football field. Okay, class is out at 1:14. That means we need to be back here in 30 minutes. Pace yourselves. You have 30 minutes to data collect. Have a seat for a second, so I can finish, so that way everybody can hear. We have 30 minutes to data collect. I would focus on data collection first. Get that done. Once you have all 4 pieces of data collected, technically it's 8 pieces of data. 9, 10, 11, 12, if you count eye height. Get all your data collected. If you have questions about it, ask me out there. Then we'll come back in, we'll do your calculations, you will submit it in Canvas, and then my last slide will be our closure for today, which we will complete. Questions before we hit the field? Please be respectful of the other classes in the hallway. Make your way quietly to the football field, going down the hallway and to the sidewalk and out.